try that, okay? I'm not even going to give you an equation here. Let's just see if we can kind of visualize how this inverse should look. So if this is our original function, so, well, I won't label it. I'll just leave it like that. Okay, so the inverse needs to be a reflection of that over that dotted line. Okay, so can you visualize that in your head? Okay. Right, that's where I'm going with this one. Yep. So that inverse, it should be another parabola like this one, except it's going to do like this, right? It's going to wrap around. So it's a parabola that opens to the right, not a parabola that opens up and down anymore. So it'd kind of come around like that. All right, and what Josh just said was the inverse is not a function. Okay, this is how we can see it on the graph, right? What is that test that we use to test if something is a function or not on a graph? Yeah, vertical line test, right? So we can take a look at this inverse that we've just created, and we particular one would not be a function when we did it. Okay, the graph that I put on there, what does it look like? What of your 12 basic functions does it look like I just created there? Squaring function, okay? So let's assume that that's what it was. If the original function was f of x equals x squared, basically like we did earlier, y equals x squared, so the inverse is x equals y squared, square root both sides, so y equals plus or minus the square root of x. So is y equals plus or minus the square root of x a function? No. Okay? So I know that what I'm getting should not be a function. And in fact, what I'm seeing here is two functions. You're seeing the square root. Think about the shape of the square root from your 12 basic functions. This should make a bit of sense. The square root, do you see it there? It's the top red parabola. Okay? And then the bottom of it is the negative square root of x. It's the same thing as the square root of x. It's just been reflected down. Okay? So this red curve is actually the collection of two functions put together. All right, and that's the inverse. Okay? So here's a question for you then. How would I, without graphing the inverse, just look at the original function and be able to tell if it's going to be a function or not when it's the inverse? Yeah. Okay, so yeah, all the examples I've done so far have been square roots, but that's not the only thing. But that's true. If you go through the process of finding the inverse and you end up with a square root as part of your solving it, it's going to be not a function. But just look at the graph itself. What feature about how it's made, and remember what I just talked about, the vertical line test tells you if something's a function. So what about the original would do that? Yeah. You're absolutely right. Yep. On the original function, if you do the horizontal line test, we'll tell you if the inverse is a function or not. Remember, x becomes y, y becomes x, right? With inverses, everything switches. So the vertical line test on the inverse becomes the horizontal line test on the original function, right? Okay? So if I just graph you something, you should be able to tell me right away. So that's I'm going to give you guys several functions to take a look at, or not necessarily functions, but several graphs, and just tell me, is the inverse going to be a function or not? Okay? Come on. Okay, so take a minute. And for each one, yes or no, and why. Okay, is the inverse a function? Maybe I should write that at the top here. Okay, so let's real quick go through this. Just calling some random folks here. So let's do, Madison. First one. Is the inverse of that going to be a function? No. No, and why not?
Because you can draw a horizontal line.
Right. So if I put a horizontal line through this, I can find where it will hit more than once. So this one, definitely no. Okay, how about second one?
Yes, it is a function.
Mm-hmm. Yeah, so it's a function because it passes the test, but it also passes the horizontal line test. So that inverse will be a function. Yep. Okay, next one, let's go for it. Is that going to be a function?
No.
Okay, why not? Correct. And not only that, what else is wrong with this one? It's not even a function to begin with, right? Okay, so yeah, definitely a no. The last one, Angel, is that going to be a function when we do its inverse? Well, does it pass on a line test? No, it doesn't. So I put a horizontal line through this one. I can get it to hit more than once. So will the inverse be a function? No. Okay. So value functions, in general, that's what this one is, are not going to have inverses that are functions. So just kind of a little vocabulary here for you. So if a passes the horizontal line test, we call it 1-to-1. Okay, and that's some terminology your textbook's going to use. 1-to-1 means 1x to 1y, and 1y to 1x. Okay. For every one input. Well, if a function is 1-to-1, it takes that a step further. It says not only is there one output for one input, there's also there is one input for every one. It goes both ways. It's a two-way street then for those. Okay, so 1-to-1 functions pass on a line test. Their inverses have functions are